This is a video investigating the probabilities of compound events. By the end of the video, you'll be able to find the probability of independent and dependent events, identify mutually exclusive events and work with them, and find the probability of mutually exclusive and inclusive events. An example of the probability problem with two independent events, thus a situation where one event does not impact the other, is found by the product of the probability of each event. For an example, using a standard deck of playing cards, find the probability of selecting a spade, replacing it in the deck, and then selecting a face card. Due to we replace the card, one probability does not impact the other. And so I would simply take and multiply the 4 out of 52 for the probability of selecting a spade, and then I would multiply that by the 4 out of 52 for finding, then taking out a face card. Try this one on your own. If you were to roll a die, find the probability of rolling an even number followed by rolling a 3. So these are independent events. One does not depend on the other one. Pause the video and then continue. So what you should have done was realize that on a die I have 3 even numbers. So there are 3 out of 6 for the first event, followed by 1 out of 6 for the second event. I would multiply them, and so that gives me 3 out of 36, or 1 out of 12. Think now, what if I hadn't replaced the card in that earlier example? That would mean that the second card's drawing would definitely be impacted on what happened with the first card. When we do this, we simply take the probability of the first event happening and multiply that by the probability of the second event, considering that the first event has already happened. For example, if I have someone with a bag containing 4 red, 6 green, and 3 brown candies, and he randomly chooses 3 candies from the bag, what is the probability he will choose all brown? Well, to figure this out, we consider that the first probability, he has 3 out of 13 for his probability. For the second one, considering that the first one happened the way we want it to, and that's the way we'll always think, he now only has 2 brown ones left, and in the bag there are 12 candies. Now for the third and final event, assuming that the first 2 happen the way we want to, and again, that's the way we're always going to go about this, there would be 1 brown candy left out of 11 candies total in the bag. We then multiply these together, and the simplified product comes out to 1 out of 286. That would be the probability of that dependent event. Again, the probability of the second event, this one, and the third event depend on what happened prior to this, because we did not replace any candy in the bag after taking one out. Now try this one on your own. We have a box of books that need to be organized on shelves. The box contains 8 science books, 4 history books, 6 novels, and 2 foreign language books. The person emptying the box grabs 3 books at random. What is the probability that all 3 books are novels? This is similar to the candy problem in that each time I take out a book, I don't put it back, and thus the following events are impacted by the previous one. Pause the video and try it on your own. What you should have gotten would have looked like this. We had 6 out of 20 for the first event, 5 out of 19 for the second, and then 4 out of 18 for the third. Each time the number of desirable books decreases, 6, 5, 4, and the total number of books decreases, 20, 19, 18. We then find the product, which is 1 out of 57. For the next situation, we will consider events that are mutually exclusive, meaning that they cannot possibly happen at the same time. For instance, on a die, rolling a 2 or a 5. When I roll that die, it could be one or the other, but not both at the same time. To find the probability of mutually exclusive events, we have the sum of each independent event. So the probability of event A plus the probability of event B. Let's consider this top example first. Gina has 6 pennies, 4 nickels, and 5 dimes in her change purse. She takes 1 coin from the purse at random. What is the probability that is a nickel or a dime? So we know right now it couldn't be both a nickel and a dime. It has to be one or the other. So I will find the sum of those 2 probabilities. So for it to be a nickel, that would be 4 out of 15. 4 out of 15. For it to be a dime, that would be 5 out of 15. That comes out to a probability of 9 out of 15, or simplified as 3 out of 5. Now try the next one on bottom on your own. It says Laura has a box of pens which contains 6 blue, 9 black, and 3 red. She grabs 1 pen at random. What is the probability it is a blue or red pen? Pause the video and try it on your own. What you should have gotten was 9 out of 18, or 1/2. That comes from taking 6 out of 18 plus 3 out of 18, which comes out to 9 out of 18. For the next situation, we will think about events that are inclusive, meaning that they could happen at the same time. However, we are not interested in the space where they happen at the same time, just where one or the other happens. So I'm interested for probability of A happening and the probability of B happening, but I need to exclude the middle region here where both happen. So what I do is I add the probability of A and the probability of B, but then subtract from that the probability of A and B happening. For this example, consider in a particular group of hospital patients, the probability of having high blood pressure is 3 out of 8. The probability of having arteriosclerosis is 5 out of 12. And the probability of having both is 1 out of 4. What is the probability that the patient has either high blood pressure or arteriosclerosis? We are not interested in the patients that have both, so what we will do is take the 3 out of 8 plus the 5 out of 12 and take away from that the 1 out of 4. This comes out to 13 out of 24. You try this one on your own. In a class of 120 students, 8 are on the yearbook committee and 6 are on the school newspaper. 4 students on both the yearbook and the school newspaper. What is the probability that a student selected at random is on the yearbook or the school newspaper? I don't want the ones that are on both. Pause the video and try it on your own. What you should have come up with is 8 out of 120 plus 6 out of 120 minus the 4 out of 120 that are on both, which comes out to 1 out of 12. I hope you found this video helpful. Good luck, have fun, and stick with it.